Hi. Hello. Can somebody hear me? Can somebody give me a feedback?
I can hear you.
Okay, perfect. I can also hear you. Thank you. And yeah, I'm so glad to meet you, even though here through Discord. And as you can see, I'm still in the classroom. There's no people in this building. It's pretty empty. And okay, let's start today. Screen. Uh, Last week we discussed our first program, which is Hello World program. So let's see. So can you see? I'm sharing my screen. Can you guys see this code review from last week? Can you see this screen? C++ code?
I can't see it.
Okay, perfect. Thank you. Yeah, I just want to make sure everything is going well because I couldn't really see you in person and I couldn't show my screen. So I want to make sure, yeah, you can hear me and you can see what I want to show. Okay, so last week we discussed our first Hello World program. And as you may remember, we started with the first line, which is a comment. If you put a 2/ at the beginning of a line, then the entire line will be commented out. It will not impact our program. And then we may include some library. And then we may use standard namespace because standard namespace gives us how do we use the functions provided by C++ compiler. And also, the execution started from a min keyword, which is here, int min. And then after min, you can see a pair of parentheses. Those signs are used to put arguments. For this example, we do not use any arguments, so I will leave it empty. Later on, for some functions, you may realize that we need some arguments, and then we will send the arguments in this pair of parentheses. And then after that, we will have braces. And all the main body of the function will be included inside of these braces. For this example, the only thing I'm doing is I'm going to print out hello world in the terminal. And the syntax is I'm going to use cout. Cout means I'm sending hello world to terminal. So cout, smaller, in a pair of double quotes. Hello world this is what I'm going to print out. And then return 0 using this way I'm ending up main function. Don't forget another brace. So this is our first function. And today, previously I planned to first discuss our homework. But some students send me email saying they have trouble to get a textbook now at the beginning of the semester. So I'm going to postpone a little bit the deadline of the submission of the homework. Get your textbook and finish your homework and upload it. And then I will talk about those two questions on Wednesday or maybe Friday once I got all the submissions from you. Okay, so for today, we are going to learn the variables and the data type of C++. So you already watched the video. Now, first part of today's class, I'm going to ask, is there any questions regarding the video? So there are a lot of details in the video and a lot of important knowledge. So make sure you're very clear on each of the points so that later we will use those knowledge. If you have any questions, let's discuss now. Questions regarding the video? If you don't have a question, I'm going to ask a small question. Not really included in the video, but we may use this knowledge later when we code. So, do you guys know binary expression? If I have a number of 3 in decimal, what is the binary of 3? If we convert 3 into binary, what it is? Can somebody tell me? And you're still listening to me, right? It's so weird to just talk like this. I don't know whether you really can hear me. Okay.
I don't know binary, or else I would answer.
Okay. Okay. Thank you. Sure. Okay. Binary is, like we mentioned last time, computers only know machine code. And machine code is written in binary, like 0 and 1. So actually, whatever our source information is, you may have numbers, you may have a picture, you may have audio, you may have video, anything will be eventually converted to binary and send it to computer because the computer only knows 0 and 1. That is what we said, binary. So from the name, you can guess it's only 0 and 1 for binary. And then goes to my question. I have 3 in decimal. To let the computer recognize 3, I have to convert it to binary. So what is the binary expression of 3? And now I'm going to show you a very simple example. Here. See, here I have decimal numbers from 0 to 8. And then on the right column, that is the corresponding binary. For example, in decimal, 0 converted to binary is still 0. 1 in decimal converted to binary gonna be 1. 2 in decimal converted to binary gonna be 1, 0. 3 is 1, 1. 4 is 1, 0, 0. 5 is 1, 0, 1. 6 is 1, 1, 0. And then I have 7 and 8. See, you may feel confused. How do we do this? How do we do the conversion? It doesn't matter really too much. If you are interested in that, you probably would like to go to Google and try to learn the theory. How do we convert decimal to binary? And that part of the knowledge is not the point of this course. We are not going to learn how to convert between binary and decimal. But I just want you to know, for computer, eventually we have to convert everything into binary, which is what you're looking at now. Is only 0 and 1s, always 0 and 1s. So, okay, we are not going to directly use this part of knowledge, but we definitely will use it indirectly for this coding course. So, okay. And okay, next I'm going to give you some examples to help you understand today's video, the video about the data type. So in the video, we learned now the data type we learned is integer and floating point numbers. So we are going to go through some examples. Okay, by the way, we will start your first programming job on this Friday. So either on Friday or maybe on Wednesday, I will help you to install the VS Code and a lot of some other softwares on your own laptop. So that may happen on either Wednesday or Friday. You will do the same thing as what I'm doing now. So have your own VS Code. So to show you the examples, I'm opening my VS Code and open my project, integer. So this is my code. And first, I'm going to run it a little bit to show you. Okay.
Your screen isn't showing up yet. It's still.
Oh, my screen is not showing.
Still shows the picture from your camera, binary chart.
Okay. Okay, thank you.
I'm seeing it switched over to the code.
You see the code?
I can see the code.
It's clear as well.
Yeah. I also see my code, but I can close, but I can turn off that the piece of paper. What if now? Can you see my code?
Yeah.
Maybe you try to, if you still see that the piece of paper, you maybe can try to switch between my video and that screen sharing and go back to screen sharing. You may see my screen code, my code. Okay. So, okay. I'm going to run this code. See, this is what is printed out. I have 6 exercises to show you different problem regarding integers. And let me explain this code. First, you can see from the first line, I have a lot of comments. See, for each line, if I have 2 slash at the beginning of the line, that means this line is a comment. In VS Code, it is shown as green. So like we mentioned, for comment, it will not impact our code. It's only some comment for human being to understand the code. Any information you want to put, you can put it as a comment. And then after that, in line 8, I include my LStream library. And the next line, I told the compiler I'm going to use the standard namespace, like we mentioned, right? In this namespace, we defined a lot of standard name for different functions. So later on, you can use those functions. For example, cout is one of the standard names in this namespace. And then next, line 16, I started my program. Started with main keyword. That means this is my main function. And after that, everything will be included in a pair of braces. See here, this is my first brace. And then at the end of the program, this is another brace. That means I end up my main function. So inside the main function, I have a lot of exercise. So to show it clear, I'm going to comment out a lot of lines. So like I mentioned, if you just want to comment out one line, you can use double slash. If you want to comment out a lot of lines, you can use slash plus star, and also another star with a slash. And then all the lines in between will be commented out. And now I only have one example left. I'm going to send exercise 1 hello CS-171 to the terminal. So let me run this code. So now, see, I only have one example printed out, hello CS. This is simple. This is actually the same as our previous example, hello world, right? You just print out one sentence to the terminal. Okay, I move the comment to the next place. So now I should be able to print out example 1 and example 2. So what is example 2? See, look at here. Example 2, first I defined an integer, a variable x, and I put int in front of x. That means x is an integer. And then next I give a value to this x. In next line, I print out exercise 2, x stores something. Stores what? Because this red line, exercise 2, x stores, is just the words I want to print out. But I also want to print out the value of x. And the way of doing so is I just smaller x, put x here, and then end up this printing out. Then whatever the value is stored in x will be printed out here. So here, exercise 2, x stores 5. X stores is the thing I put here. Actually, you can change it like. So I just randomly add something to show you the difference. So here you can see x stores really, right, number.
What does
Yes?
stores? Why is it there?
I put it there. You can change it. Like here, x is anything. It's just the word you want to print out, like hello world. Anything you put it inside of a double quote, it's just the words you want to print out in terminal.
Gotcha.
Yeah, you can change it.
Why do you have the smaller x smaller?
That is the syntax. Like, okay, how do you print out the stuff? First, say out, and smaller. That is the syntax. And then any words you want to print out, you put it in a pair of quotes. But inside of the quotes, you can change it. You can change it to anything. Before it was stores, and now I change it to is. So you can see also. Okay, I give you 2 lines. Stores and look at here. Now I have 2 printout lines. One is the original one, stores. Second one, I want to say x is or something, anything. So now you can see here, I have 2 lines. X stores, X is. So inside of those double quotes, you can change it to anything. And then it will be just a printout. And smaller, and the pair of quotes are the syntax. Those things you couldn't change. Like you can do this. See. See, the first line is exercise 2, x stores the value of x. The next line, I delete everything inside of the codes. So now nothing is printed out except 5. 5 is this x, the value of x. Does it make sense?
Yes.
Oh.
Now, did you have to separate the exercise stores and the value of x by the smaller, or could you have put them in section?
Put it where?
So you have the x separated from the example store by two smaller signs. If you removed those two smaller signs, so that you wanted to print out was only smaller signs.
Do you mean this? Do you mean this, like this?
Yeah.
Let's see. No. See, now it gives me errors. No, it doesn't work. You have to put it. Yeah. This is compiling. It doesn't pass the compiling process. It doesn't work. It gives me error. See that here? Error. Expected something. He thought the programmer, the compiler thought this program should be end up here because I deleted the smaller. That is why there's an error. Because, yeah, sure. Because here it is the expression, and here x is a variable. There are two different kinds of stuff you're going to print out. So you have to separate it using a smaller. Yes. Okay. And another thing is we define the integer x and immediately send the value to x. And I can do this thing using a different way. I can also first define x and later send a value to x, like this. First, I define the x, a variable x, and now there's no value sent to x. I just define the x. And later on, I give a value to x. That also works. See, same. Exercise 2, x stores 5. So, yeah. Okay. And the next example, we're coming here. The third one. What I'm going to do is still this x. It was 5. And now I added 1 to this x and still send the result to x. X was 5. The meaning of this line is I added 1 to x. Whatever x is, I added 1 and still send the result to x. And next, I'm going to print out the value of x. So now exercise 3, x stores 6. So x is changed from 5 to 6. Now x stores 6. Questions? Then I'm going to the next example. Next, say I give x a different number. Before, at the beginning, x was 5, and then I change it to 6 in example 3, and now in example 4, I'm giving a totally different number to x. So still, that is x. But now I'm giving x a very large number. And later, next, I'm adding 1 to this large number, and then print it out. So now I have one question. What do you think will be printed out for example 4? What X is now? Any answers?
It'll be that big number plus 1.
That 2 billion number plus 1?
Mm-hmm.
Yes, that is a reasonable answer. But for this C++ code, maybe not right. But for math, if you answer this question in a math class, your answer is right. But in this class, it will give you different answer. Let me run this.
Oh, is it because it's not defined?
No, not that reason. The syntax is right. I define X here. You only need to define once. Yeah, remember that. I will show you another thing. That is a very good point. See, if I define X again, what do you think is going to happen? I define X here already in example 2. But now I define X again. I define it twice. See now, error. And the error is redeclaration of int x. That means actually you are not allowed to declare one variable twice. So, yes, it's not because I... Sorry?
You have X, yeah, right now you have X5, and you also have X, that big number.
Yeah.
Which one is it going?
Okay, very good question. Very good question. How do I answer this? Let me think. Okay, is there some examples in our life? Yes, it's more like I'm writing some sentence on my blackboard, on my board, the board behind me here. So first, if I draw a picture on this board, and you see a picture, and later on I want to do something else, so what I'm going to do is first I need to erase anything on the board, and then I draw my second picture on that. So the second picture just gonna erase and cover the first picture. This is the same example for this x. X was 5, and later on I did some calculation. X becomes 6. 6 also is sent to x. So 6 will cover 5. 5 will disappear, and 6 will be stored in x. And later on, I give a very large number still to this x. That means 6 will be erased, and this large number will cover 6. That is what's going on with one variable. If you are keeping using the same variable, the new number will always erase and cover the old number. If you want to keep 6, okay, if you want to keep 6 in x, and also you want to send a large number to some variable, that means you need to define a different variable. For example, y. You can define y and send y to send a big number to y. Then you will have a large number in y, and you will have 6 in x. But in this way, now in this code, the large number gonna cover 6. So after line 31st, x will just have this large number. 6 is not there anymore. So now, what do you think will be printed out in line 34?
Will it be the negative of that big number?
Yeah, that is a very close answer. Very close answer. Good point. Let's try. See, now you can see exercise 4, x stores negative 2 billion, blah, 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 48. And my number is positive 2 billion, blah, blah, 47. Yes, it becomes negative, but not exactly the same. 47, 48, right? So this is an interesting result. And to explain that, we need to go back to our video. Where is the video? See, now I'm showing this slide. Sorry?
I'm just confused what you changed there to make the outcome not an error.
Oh.
I missed that.
The error is because I double defined the same variable.
Right.
I put
So
this. Yeah, I put this. I defined x before for the first time, and now I define it twice. So for the same variable, you couldn't define twice. You couldn't declare it twice.
okay, so you use that.
Yeah.
You use that int command twice, and that's what gave you the error.
Yes. Use
Okay.
int x twice. That is the reason of the error. I just deleted it.
Got it. Thank you.
Sure. And also for that number in the slide, in the video, we explained that, okay, for the signed integer, we started from 0. And if you add 1 to 0, you got 1. If you add 1 to 1, you got 2. If you add 1 to 2, you got 3, and so on, until I go to 2 billion, blah, 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 647. And the next large number in the positive side is 2 billion, blah, 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 48. We didn't show it here, but the maximum positive number is 2 billion, blah, 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 648. And then if you add 1 to that number, it goes to positive. It goes to negative. Oh, sorry. No. Yeah. Excuse me. I didn't say it right. The maximum positive number is 2 billion, blah, blah, 647. And if you add 1 to this number, it goes to negative. It's going to be negative 2 billion, blah, blah, 648. That is what happened in that code. In that code, this number I give to x is the maximum positive number. Then I add 1 to it. It becomes negative. Negative 2 billion, a lot of numbers, and 648. And now my next question is, if I add 1 to this negative number, what do you think it will be? For example, if I change this code a little bit, I just copy these 2 lines here. I don't need this comment here. So here, after line 34, you got a negative 2 billion, blah, blah, 48. And then I add 1 again. What do you think will be printed out in line 36? Let's see this. See, now you can see, previously, after adding 1 to a very large positive number, I got this negative 2 billion, blah, blah, 48. And then, in this line, I add it again. I add 1 to this negative number, and then I got a negative 2 billion, blah, blah, 47. Like this. How do you go through? How do you go through this circle? You go in this direction. Adding 1 to this negative 2 billion 47. Adding 1, next number gonna be negative 46. And add 1 again, gonna be negative 45, and so on, until negative 1. Yeah, this is how do you go through this circle if you keep adding 1. And the tricky part is from how y after I add 1, a positive number becomes a negative number. To understand that, you need to understand how does the computer express a negative number in binary. See, before in that paper, I showed you how to express positive number in binary, like this. Like this here. Here. For example, 2 in binary is 1, 0. And this is positive number. But what if now is negative 2? What is the binary of negative 2 in decimal? So, only when you understand that, you can explain why adding 1 to a very large positive number, it becomes negative. But this part of knowledge is not the point of this course. In this course, we are not going to discuss this. You just need to understand for integer or variables in C++ programming language, the maximum positive number is this 2,147,000,000 blah, 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 47. That is the maximum in positive side. Adding 1, it becomes negative 2 billion, this thing. You only need to understand that. You also don't really need to remember this number. You only have to know those features of integer in C++. That's enough. Questions?
So if you write down a number bigger than that number for x, will you get an error?
Good question. Let's try. Add 0. Very good question. Yes. You got the overflow. You got the overflow. Yes.
Thank you.
Yeah, sure. And then let's move to next exercise. So here, still x. I'm doing a division. 17 divided by 4, I'm going to send the result still to x. So let's, as we explained, this result will overwrite this large number. Not this large number, that's a negative number after adding 1. Yeah, we'll overwrite it. So now my question is, what do you think now x is? What's going to be printed out in line 39? No answer?
Would it be 4?
Yes, it is 4. Exercise 5, x stores 4. Here. So you may wondering, why is 4? Where is my fractional part of this division, right? And the reason is, in math, yes, it's not 4. The result is 4 point something something, right? Let's see, what is that something something? Calculate. $17 divided by 4 should be 4.25. Okay, but now the output is 4. The reason is, okay, go back to this x. X is actually integer. So all the fractional part will just be cut, will not be stored because x is declared as an integer. So the result is going to be just 4. I'm going to show you another example. Say, if I declare a float part, y equals 217 divided by 4, and then say out. Y stores y. So now I just added 3 lines here. I declared another variable, but this y is a floating point number. So still do the same calculation and print out y. So now here, what's this? Oh yeah. Shouldn't do this. Divided. Oh yeah, no, not here. See now y is 4.25 because you declared y as a floating point number, and only in this way you can still keep your fractional part. Otherwise, for x, because it's an integer, the fractional part will be cut. But floating point number we will explain in the next example. Next example we will learn the floating point number. Okay, so delete it. Next example, I'm going to ask the compiler what is the size of x. So first, simple, I just print out exercise 6 x requires, and my focus is how large x is, and I'm using size of. This size of, okay, is a standard function provided by C++ compiler. So it's just a function. It's just x, just get the size of the variable, the size of anything inside of the parentheses, and then return me a number. So we have learned in the video that the size of integer is 4 bytes. So now let us see what's gonna be printed out. So look at here. Exercise 6, x requires. X requires is what I want to print here in line 42. And then size of x, I got 4. Because the integer variable has 4 bytes. 4 bytes of memory. Bytes of memory was printed out by line 44. So now, one question. What does it mean when I say 4 bytes? Okay, how many bits 4 bytes has? Okay, simpler question. How many bits 1 byte has? Somebody know this? How many bits 1 byte has?
1,000?
1,000? No. Not 1,000, also not 1.
8.
Yes, 8 is the correct answer. 1 byte has 8 bits. And 8 bits is just a binary, right? Bit is a binary digit, either 1 or 0. That is 1 bit. So 1 byte has 8 bits. So 4 bytes has 32 bits. Look at this paper. And now on the bottom of this paper, so here first I wrote 8 bits, 01010101. That is 8 bits. That is 1 byte. I just randomly write 0 and 1. What it is doesn't matter. I just want to show you now I have 8 bits. And then I wrote another 8 bits. So this is my second byte. And then I have a third byte. Then I have a fourth byte. So all the 4 bytes put together give me 32 bits. That is one integer. That is how large one integer could be. So of course, this is in binary. 0101, this is in binary. To know what is the decimal number of this 32-bit, you have to convert binary to decimal. That is one integer variable in the form of binary here. Yeah. This is 4 bytes. Okay, this is the example I want to show regarding integers. Questions? If you don't have a question, I'm going to go to the next example, floating point number. Same. I'm still going to comment out some parts so that you can read it easier. So now I comment a lot of lines. I only keep 2 lines. One is I just want to print out exercise 1 illustrate of floats, and then exercise 2 my pi stores. Of course, before that, my pi is the name of the variable. My pi is the name of the variable. And when I declare it as a floating point number. I put the keyword float in front of it. And immediately after that, I send a value to my pi. And then I try to print it out. Let's run this. So now the first exercise is simple, just print out 1 sentence, similar as hello world. And the next example, let's see here. Exercise 2, my pi stores the value of my pi. And now you can see what is printed out is 3.14159, which has less floating point number compared to the number I gave to my pi. Why this happens? Because as we mentioned, the size of a floating point number in C++ also is 4 bytes. And 4 bytes, you couldn't store as much decimal number as you want. If you give a very long part in the fractional part, some digits will be cut off because of the storage limitation. So usually for a floating point number in C++, you can store totally maybe 6 or 7 digits put together, including the whole number part and the fractional number part put together, 6 or 7. It depends, it's not always the same. But definitely it couldn't store this long. So you end up with 3.14159. Questions?
Is there another type of variable that can store more bytes?
Yes, you have long floating point number. Let's see here. Go back to the slides. See, you have a floating point number. That is what we are using for my pi. It stores 4 bytes. It has 4 bytes. And then you can also define it as a double float. In that case, you will have 8 bytes to store it. In that case, you can have more fractional numbers. Okay. Next, my exercise 3. Yeah, that's what I'm going to do. Similar as that integer, I'm going to read the size of my pi and print it out. As we can assume, this number should be 4, right? Because we said the floating point number requires 4 bytes to store. So exercise 3, my pi requires 4 bytes of memory. Next. Next is here, example 4. What I'm going to do is, see here, I defined 4 variables. All of them are floating point numbers. Radius, area, cost, value. So I just defined it, but right now I didn't send any numbers, send any value to them. I just declared 4 variables. And later on, I give number 9.5 to radius, which is a floating point number. And I did some calculation about the area. My pi times radius times radius. That is how do we calculate the area for a circle, right? And then cost, I give a number 5.99. And then for the value, I did some calculation. Cost is divided by area. So you can assume what I'm going to do for this value is I want to know how much for each inch square of the pizza. This is a pizza, assume. So I just print out the 9.5 inch pizza has a value of what? I calculated the value. So now let's print this out. So here, the 9.5 inch pizza has a value of 0.0211 per square inch. So for this example, my point is I try to calculate the value of a pizza. This is exercise 4. So questions? Okay. Then if I move down, my next 2 examples are very similar. I defined another size of pizza, 11.5. I give this size to radius, still calculated the area, and give the cost. This pizza cost $7.99, and I calculated the value. And again, for a larger pizza, I did the same thing. So the 11.5 inch pizza has a value of this, and the larger pizza has a value of this. So from those 3 examples, you can see using C++, we can do some math calculation. What I need to do is I need to input the function for area, or function for the value. I input the function, and then I send the initial number of this function, and then C++ can help me to do the calculation, get the result of value. And here I'm using floating point numbers. Okay. Though these are the example for floating point number. Questions? I forgot whether I mentioned it or not. For the office hour, if you have any questions later, if you have questions regarding installing the software VS Code, we will show it later on either Wednesday or Friday, and we will go through it one step, one by one. And other questions regarding today's lecture, you can come to me during my office hour. Office hour is listed on the syllabus, and now we are doing the office hour online. I will be there on Discord during the office hour. So any questions regarding the lecture, you can come to me during office hour. If you want to meet me in person, send me an email. Sometimes I will still in office, but send me an email before. Make sure, yeah. Okay, so that is today's lecture. Thank you, guys.
Thank you.
Thank you.
You.
Nice.
Yeah, have a good day.
Thank you.
Yeah, thank you.